Anybody want to see 15? Or we good? All right. I thought 16 was a little harder. I wasn't quite sure where to go with that. Hi. What did you try? 16. Thank you. Root test. I tried root test myself. I thought that was natural, at least because of the exponential. So let's see where we head with the root test, and we'll talk maybe something else. Now, obviously, then the root test goes great. Oops, no, I'm doing that. Great for the denominator, 3, yeah? Wasn't quite sure what to make out of this bad boy here, yeah? What did you say about the top? Isn't this infinity to the 0? And is that, is that determinate or indeterminate? Indeterminate. That's indeterminate. But I didn't want to do all that log stuff, so I kept going and I thought about it slightly differently. You might have done the same. Can't we do these in either order? So couldn't I do n to the 1 over n and then to the 3 halves? Is that possible? Is that cool? What is the nth root of n as n goes to infinity? 1. And so you get 1/3, which is less than 1. But I don't feel super. I'm 70% confident in the root test. It's not my favorite. To really be sure that I want to pick up a calculator and verify. So, say you did a ratio test. If you did the ratio test, what did you get for a limit? 1/3. I think that goes cleaner, and that is easier to find convergence on, but it does converge. Are we good on one of those two? Anybody try anything besides those two? Okay. All right, and then 18, what's the natural there? DCT. Yeah, DCT, you have to start from the factor. You have to have this down. That's just something you have to have in your Calc 2 toolkit. That's a fact you need to know, okay? So if you don't know how natural log compares, this jump is what allows me to take natural log and compare it to something with powers so we can do p-series, right? This is, when you divide, you eventually say less than a p-series and it converges by comparison with p-series. You with me? It does go okay? Okay, great advice, or great energy on that response. Excellent, excellent, thank you. Okay, now if you think you're tired on a Friday afternoon, all you gotta do is sit there. I don't understand why I should feel sorry for you. I'm the one doing all the freaking work. Okay, all you gotta do is, I'm so tired. Jeez Louise, I mean, come on, people, talk to me here. All I'm asking for is or yep. Okay, there we go. Way to go. Okay, so here we go. This is a little different angle on polar. You've done a lot of integral calculus on polar. You've done area inside polar. All of that is integral. This is differential calculus with polar. Good stuff. It has applications to physics and stuff like that. I don't know if you do anything physics or not, but it definitely has some, also in astronomy. But let's start here. You need to understand the nature of dr d theta, what that derivative indicates. Let's compare it to what we're used to. If I asked you what dy dx is at pi over 2 for this yx function, then what is dy dx? -2 sine of x, and assuming then we throw an evaluation bar at pi over 2, we get -2. Okay. It doesn't say to graph it, but what is the graph going to look like? Tell me some attributes of the graph. Okay, it's a sinusoid because it's y and x. What kind of shifts or stretches? Okay, it's shifted up 2, and it has an amplitude of 2, yeah? So it will look something like this, yeah? Do we agree? Okay. And a normal period of 2 pi. And so when we If we are to graphically show the meaning of our answer, dy dx of pi over 2 is the slope to the curve, right? The tangent slope. So we could say the slope tangent to the curve at pi over 2 is -2. An alternative that might lead in a little better to the next question is, if we also consider dy dx as -2 to 1, then that seems like for every move right of 1, y will decrease by 2, yeah? I guess you could also put the negative on the bottom and say for every left of 1, the graph goes up by 2, and that's fine too. But we could and then all that is really just slope in a different way. You agree? Okay, but it is very much how y is changing as x changes. Now, if you consider the difference then when we talk dr d theta, I think you can see that the equation is the same, and so the outcome to the derivative will be the same. You'll still get -2, but the meaning now is different. Let's start with the graph and then do the interpretation. Where's the graph of that equation in polar? It's a totally different graph, obviously. It is a cardioid with a max R of 4 and a min R of 0, and it looks something like that, yeah? Now, say you said, oh, no, just a derivative, it's slope still. Well, here's pi over 2. Does that look like -2? Most definitely not. Okay, so dr d theta is definitely not slope, because slope is rise over run, y change over x change, and we're not dealing with y and x here. We're dealing with r and theta. So let's look at this. Oh, why would I do that? Okay, let's look at this different. Remember, r is the distance from the origin. I know it feels like r for radius, but we're not dealing with circles so much. It's just distance from the origin. All right? How far you go from the origin. And d theta is the angle. Theta is the angle you turn from the positive x-axis. So when we get a result of -2, that means that as we turn in a normal way, so d theta is positive, yeah, so as we turn in a normal way, as we go along the curve, the distance from the origin is decreasing, okay? And that's pretty common. You would say at theta equal pi over 2, the distance from the origin is decreasing. Sometimes they phrase it as a particle on the curve, in which case you'd say the particle is moving toward the origin. Is that always the case? That if the r d theta is negative, you're moving toward the origin? So what do you mean? You're on the right track, but no. So what if, when dr d theta is negative, that means r is decreasing, right? So when might that be moving away from the origin? If r is negative, yes. If r is negative, then you're already backing up. And then if dr d theta is negative, you're backing up even more, right? And so it could mean away from the origin. Now here, you're going forward. And so a positive r with a negative, it's kind of like that speed calculation. Do you agree? Depends on the interaction between the sign. Think of it like this. If I said you're on a number line, and I told you dx dt is positive, does that mean you're moving away from the origin? You're on a number line, and dx dt is positive. Are you moving away from the origin? Depends. Give me elaborate.
If you're negative, then you're moving towards it, so you're moving to the right.
Okay, so it would matter where you are in reference to the origin. If you were in a positive position, and dx dt was positive, then you would be moving away. And yes, the opposite is true. You with me? So you need to take into account is r positive and dr d theta positive, or is there a mixture of signs? Okay. Do you understand what I'm saying? I'm kind of tired. I don't know if I'm saying it straight. Do you understand it? Okay. If not, I'll clear it up. Okay. Let's move on to another idea. I just want to make sure that you understand the nature of polar versus rectangular. This, if I say graph 2 plus 3i, graph it, where do you go? Right 2 and up 3. Now, this point is totally different than this point. This is the Cartesian plane or the coordinate plane. These two things are not the same. 2 plus 3i has an imaginary component. It's a totally different way of graphing, understood? It's just different numbers altogether, complex plane. If I said, though, hey, what's this point on the graph? Give me directions. You could give me directions two different ways to get there. What's one way to give me directions? Go right 3 and up 2, and we call that x's and y's, the rectangular plane. Now, when we graph x's and y's, which you've been doing since day 1, algebra 1, it makes sense to have a rectangular grid because you're going to go horizontally and vertically. You've got to have a grid like this, right? But if it's polar, then it's more about as you turn angles, you go out so far in any direction. Well, if I want to talk about how far I go out in any direction, this doesn't do me any good. I need a circle that shows how far I go out in any direction, right? What I want you to understand is whether I give you a rectangular grid or a polar grid, r theta, it's all the same. It's still all on the coordinate plane. It's the same either way. Just different ways of getting there, but it's still all the real plane. Are we cool? Now we converted using some facts here. Would you draw a quick picture here with x, y, r, and theta? And remind me of the 4 conversion facts for rectangular or polar, or vice versa.
Squared equals y squared.
Equals r squared. What else? Oh, later on next year you'll do spherical coordinates and cylindrical. So cool. Go ahead. Sorry, I r cosine theta is x. X is r cosine theta. Y is r sine theta. One more. Tangent or inverse tangent, depending on how you look at it. Theta is inverse tangent of x over y or y over x. Y over x. Okay. And you could also say tangent theta is. All right. Now, question of the day, or the big part of this lesson, is how do you find slope of a polar curve? It is most definitely not dr d theta, because we just established that has nothing to do with rise over run. That is change in difference from the origin. It's just not slope. Okay, it's not rise over run. Not rise over run. All right. It's pretty intuitive though. How do you reckon you find slope? Okay, rectangular. It is very much you need a rectangular component because that's rise and run. How do you find dy? Dy d theta over dx d theta. Now that is true, requires a little more specificity here. You know that y is r sine theta. You just said that that's a big idea, right? And if I want to take the derivative of y just with theta, then I don't want y as a function of r and theta. I want it just theta, so what should I do? Good try. No, that's R is still in there. Okay, so let's go with, you would put the equation in for R. For that problem, they will say R equals 2 plus sine theta, and so you'll put the equation they give you in for R, and then it's just the equation plus S times the sine theta output. You follow? And likewise, if x is r cosine theta, then you would take that and say that's the equation times cosine theta, and then you take the derivatives. You follow? Let's do one without a calculator and then one with a calculator. Here we go. Say we wanted the equation to the cardioid at pi over 2. Now, if it's possible to draw a picture, you should, because that keeps you on track and is a check of, does my answer even make sense, right? So we're looking for that blue line. That's the equation of the tangent line of pi over 2. Are we good? Okay. The point, so just like any tangent line, you need a point and a slope. And let's be clear, when I say find the equation of the tangent line, you're not going to do it in r and theta. It's going to be x and y still. Equations of lines are not pretty in polar. It's pretty gross, especially when they're not the origin. All right, so we're still doing a normal tangent line approach, and so we still need a point. Now the point, if you know the graph, that's the easiest place to go for the point. Otherwise, we have to use r cosine theta and r sine theta. So what is the point of tangents? 0, 2. Okay, are we cool? Because that theta equal pi over 2, that's what x and y are, is 0, 2. Follow? Okay, cool. The slope, like any time you find a slope, you should communicate, hey, this is how I'm finding it. This is the calculus I'm doing. I'm finding dy dx at theta equal pi over 2. Cool? Now, that is, as we just said, dy d theta over dx d theta. And all that's great, but at some point I'm going to have a y theta equation to look at. So let's go off to the side and say, well, y is r sine theta, and r is 2 plus 2 cosine of theta. And so y in terms of theta is something like 2 sine theta plus, that's the easiest way to look at that, 2 cosine sine. What's the maybe cleaner way to look at 2 cosine sine? Sine of 2 theta, okay? So that's cool. Now we're ready to take the derivative. What's dy d theta? 2 cosine theta plus 2 cosine 2 theta. And we'll evaluate that in a second at pi over 2. Now let's also find x, so we can find dx d theta. X is r cosine theta, right? And so if I put in r, distribute the cosine, wouldn't that be something like 2 cosine plus 2 cosine squared? Stop me if you disagree or you don't understand where I got that. Okay, so what's the derivative? Negative 2 sine theta plus, probably minus 4 cosine theta times negative sine theta, yeah? Okay, cool. At pi over 2, at pi over 2. What about the numerator? 2 cosine pi over 2 plus 2 cosine pi. Yeah, I get 0 minus 2 or negative 2 up there, yay? Okay, denominator, negative 2 sine pi over 2 minus 4 cosine sine. Yeah, I get negative 2 plus 0 or negative 2, so the slope is 1 or negative 1. Does that jive with my picture? Yeah, okay. So my equation in my line is y minus 2 equals 1 times x minus 0 over just x, yeah? And it's y equals x plus 2. Which makes exact sense with my picture. Are we cool? Alrighty then, let's go to calculator time. Let's start by putting our calculator in polar mode and graphing this bad boy. I have no idea what this graph looks like. Some kind of rose mixture, perhaps? I don't know. So, go to menu, change your window to entry, graph entry polar. I think it was 2 sine. Was it 2 sine 2 theta? Theta, where's theta? In the pi button, in that little pi submenu down at the lower left corner, you'll find theta. And then was it 3 cosine 3 theta or sine 3 theta? Cosine 3 theta. Cosine. Cosine 3. I'm so slow. 3 theta. Did I make a mistake? Oh, I did. I typed it in wrong, didn't I? 3 cosine, where did I mess? Oh, 3 cosine 3 theta. Okay. Are we cool? Do we all agree with the graph? Okay. So, say we wanted the tangent line. Let's start by hoping that things go, oh crap. Things go well. Go menu, analyze graph. Actually, let's see trace. First of all, let's see if we can get a point in trace mode, all right? So try graph trace. And go to just 1. And nothing. Ooh, that's kind of fun though. Whee! Kind of cool. Okay, mesmerizing. At any rate, it doesn't let me type in, is this 1 radian? But it doesn't tell me what it just tells me what r is, not the theta, not the x and the y. Okay, so trace sucks because it doesn't give me x and y, all right? Now let's try derivative. Analyze graph, find the slope, and it says, okay, what graph? And I say this graph, and this graph, this one, this equation here. And I think you can see that that function is not enabled in polar. The graph does not, the calculator cannot find slopes in polar mode, although on the 84 it can, I mentioned. So I guess we have to know stuff. So that stinks. We're going to have to go to the home screen and do some thinking. So how can I find the point? How can I find the x? Plug it into r. Is x equal to r? X is equal to r cosine theta. Okay, so if x is r cosine theta at theta equal 1, now I don't expect you, do I need you to write? I feel like r is defined, so when you say r, I know what you're talking about r. I feel like that's enough on your paper. And now let's go to the calculator. Let's call up r at theta or 1? 1, and then multiply it by cosine at 1. And I get an x of negative 0.622. You follow? I don't think we're going to need that later, so I don't think you need to store it. Negative 0.662. Any questions so far about the x? All right, find the y then in very much the same fashion, but with sine. I got negative 0.968, or 969 if you like. Okay, negative 0.968. All right, so we have our points, and we're ready to go on to the next thing. What do I do next? Slope. Okay, so here's where at least the Inspire makes it easy to do huge complicated expressions. To me, this is the communication component. I have to see how you're finding the slope, which is always dy dx, but how you find dy dx is a little more complicated, which I'm demonstrating. And now it's calculator time. Are you ready? Okie dokie. So let's open a gigantic old fraction. Love that fraction function right there. Boom. Okay. Now in the top, I want a derivative in the calculus menu. I normally just jump the first thing, but in this case, the variable is theta. So I need to change that to theta. At what value? 1. First derivative. And what am I going to take the derivative of? R sine, or R cosine? R sine. Why R sine? dy dx. Okay, so R at 1, sine of 1, or R of theta, sine of theta? If I do R of 1, sine of 1, and take the derivative, what will I get? 0. That's a constant derivative. So that's so. Okay, so theta, sine of theta. All right, and in the denominator, I am going to do, will that lack of multiplying cost me? Sometimes the calculator hates that. I'll see how it goes. All right, again, change it to theta, value of 1, and in the denominator, it's our cosine theta, right? Right. There should be a keyboard shortcut for theta. Is there? I wonder if there is. It's a lot of typing. All right. I feel like I have that set up right. I'm getting 5.0125. How about you?
Yes.
Alrighty. 5.0125. Therefore, my tangent line is something like y plus 0.968 equals 5.0125 times x plus 0.662. And we are. You follow? Okay. Is that it? Oh, super. Okay. Questions on 133. You used to have 133, yes? Okay, what do you have on 133 first? 133. 133. 25. Don't you wish, I mean, Friday afternoon, don't you wish you could just go home, block 7 hours? I know it's, the next year you'll be in college, you could block whatever you want. Block all your classes. All right. What did you say, 133 what? 25. 23. 17. Okay. So 25, so 25, this is a test of whether you're a rule follower or you're a weasel or you're a really smart weasel. Okay, I've got this big table with lots of data. And as far as I can tell, it never tells you what method to use. So, you can use trapezoids, you can use left rectangles, you can use right rectangles, you can use midpoints. But more importantly, the number of rectangles is also apparently up to you. So, what is the easiest way to approximate? One right or one left? I guess it doesn't matter. They're both easy. But one right is just, so if you did it that way, I guess I can't, they did, it's their fault. They should have said, but if you said RM with n equal 1, the area is 0. Trapezoids, you're a real overachiever. Way to go. I think the answer in the back of the book was trapezoids. But I don't, if your question is, how do you want me to do it? I actually did midpoints because I don't know why. I just did. But whatever way you choose to do it on. Okay? Does that help? Okay. 23. Hey, of course, if you did this, then you should probably write next to it, I am a... Okay. 23. Question on 23. Okay. Is the problem the derivative or the critical number algebra kind of stuff?
Jerry, what'd you get for trapezoid? Yeah, I just did trapezoid stack. The back. Yeah, it's back.
And that was the back of the book was trapezoids?
Yeah.
Did you get what they got?
I did trapezoid. I wrote everything out. Yeah, I wrote everything out.
You got the answer from the back of the book?
Yeah.
What if they use trapezoid?
Well, I felt like using trapezoid. Oh, I don't think that works. I'm just lazy.
Yeah, I guess. Okay. Yeah, I would love that if you had trapezoid work at a rectangle answer. Okay. So that is the derivative. Do you agree? Okay, so with the x's dumping. Is it okay to dump those x's? I think it is. Okay. Y, that's y prime, sorry, is log of x times 2 plus log of x. Okay, so, I don't know, maybe it's because I yelled at you about critical numbers yesterday, but the domain is basically the domain of log, which is to say no, all positives only. So in terms of critical numbers, the undefined places are fine, but they're probably not in the domain because all those undefined logs were dumped to begin with. So if your worry was, well, what about the undefined? So they're non-issue. Those are excluded already. So just think log of x is 0, which means x is e to the 0 or 1, and log of x is negative 2, so e to the negative second. And those are both in the domain. They're both positive numbers. So those are your critical numbers. Does that make sense? Did I answer your question? Okay. 17. Question on 17. 17 is... This isn't the place to use.
No, it's the volume.
So the volume of an improper integral. All right. So you have 1 over x to the 3 halves, and it has the same asymptote, but probably a slightly different shape to it. 1 to... And it's around the x-axis or the y-axis? Oh, that's interesting. Okay. All right, so did you use x or y? By way of review, if you use x, what's the method? Shells. If you use y, what's the method?
Washers.
Washers, okay. So did you use x or y?
X.
X. Okay, so if you use x, looks something like that. Remember the idea is unwrapped rectangles where the thickness is the differential, in this case x, the bottom is the circumference, and the height is the height. So from 1 to infinity of 2 pi, what's your r?
The function.
X, and the height is the function, yeah? And it's dx thickness, sweet. Okay, so the volume is the limit as a or whatever goes to infinity, 1 to a of 2 pi x to the negative 1/2, yeah? Feels like this is going to be diverging, is it?
Yes.
Alright, so you can see this is going to come out diverging because when you integrate this, and raise it by 1, it now becomes into the numerator. This power rule. And as a gets really big, that's just going to get infinitely big, and the minus 1's not going to change that. So it's divergent. Shall I continue, or do you see how it's going to be divergent? We're good? Okay. Anything else on 133? 133 extra practice. Let's go here and get answers. First of all, 2 mistakes. First of all, my bad. On 133 extra practice, both on the back. First, at the top, the delta x is not supposed to be 1.4. That doesn't make any sense.
That's why
Delta x is supposed to be 0.1. Sorry about that.
you get C.
Furthermore, the differential equation is a bit of a, I forgot the name, degenerative. The way I had it, I screwed up. It should have been negative 2x, y equals negative 2x plus b for part. So on the back of last night's homework, part B should read step size is 0.1. Are we good there?
Yeah.
And part C should be find the value of b for which negative 2x plus b is a solution. Negative. I don't think it has a solution if it's positive. It's not possible. So, it's been a while since I took the computer, which was a bit of a disaster. Okay, so with that said, let's talk some answers. What do you say? What do you say? Finishing the old week strong, am I right? Okay, so let's go here. The first multiple choice. Did you get? That's not it. Where is it? Did I dump the slide?
Did you end up figuring out number 4?
That's
Yeah.
correct.
All right.
Here we go. On the front, for number 1, did you get C? For 2, B? 3, B? 4, A? Oh, you guys are so smart. 5A, what did you say for possible methods of convergence proof? DCT? The proof of that is pretty, I don't know-ish.
But it's possible. Yeah, it's possible.
Is it? I think you can prove it's not possible. So, n squared, where did you go to prove? I assume you're trying to prove it with n squared?
I'm going to do it.
Okay,
That's
so
what
that's the thing. I feel like here you're good there. That's true. But now where do you go? You're going to add 3n to both sides, in which case now this. Okay, so I feel like direct comparison test is a yet. What else? LCT. I guess you can integrate that. That's true. I do have that as well. Integral test. What else? Telescoping. Those are my intentions. Definitely my intention for part B. When it says find the sum, there's 2 possible things going on. What are they where you can actually find the sum? Geometric and telescoping. It's got to be one of those 2 if they say find the sum. So telescoping is it. Obviously, it's not geometric. So if you approach this in a telescoping way, did you get a decomposition of 1 over n minus 2 minus 1 over n minus 1? Yes? Did you get that decomposition?
Yes.
Okay. Did you get a sum formula of 1 minus 1 over n plus 1? And did you get the limit of that, the partial sums? The partial sums approach a limit of 1. And therefore it obviously converges, yeah? Okay, on the back side, I should have graphed this earlier. A was the slope field. How do you feel confident with your slopes? You had maybe negative slopes over here, like that, yeah? And this slope was 2, and this slope was 1, and steepest, very steep, very steep, very steep. Something like that, yeah? And very roughly, again, there's not, just do you have a clue? 1, 1, did that, your curve look something like this? It doesn't have to go through the origin, just have that parabola kind of shape. Up to the right and up to the left. Okay? If it goes lower, fine. If they don't get that picky. Are we cool? Okay. Now, so CX plus B. Golly, do we have time? Yeah. So you might need to recalculate B because you have a different delta X, yeah? My bad. Should I give you a minute to do that? Just give it to you? Will that help you? On the 18th? Teach a man to fish and all, darn it. What the heck? So no, do it yourself, I'll give you more time. C is hard. Should we talk about C?
Yes.
Okay, C is one of the harder questions. It's pretty rare on the AP test, maybe every 3 or 4 years, but with your luck, it might be this time. So, this is a different font, but it's the same question, and it was negative. See that? Darn it, I typed it wrong. So y equals negative 2x plus b is a solution to the given differential equation. Find the b. Now, this always pooped me out when I was in your shoes. What the heck? Obviously, that's a line, and the differential equation for a line should be the differential is a constant, yeah? And so how is it possible that the differential could be that weird? Well, it can happen if you back substitute the equation into the differential equation. I'll explain. Let's just go here. Tell me 2 things you know about dy dx. Give me 2 facts about dy dx. dy dx is, the first one just requires vision. dy dx is? You did?
Yes.
Are you sure?
Yes. Many people said it.
Oh, okay. I'm just, it's suspense then. I'm writing it slow. All right. 2x plus y, yeah? What else do you know about dy dx? Why is it negative 2? Because that's, yeah, if this is the equation, then dy dx also has to be negative 2, yeah? Okay, cool. All right, great. Where's b? Now, like I said, this often involves substituting the equation into the differential equation. So, look to substitute the equation into the differential equation. What do you get? And by the equation, I mean the actual no derivative equation. Y is equivalent to negative 2x plus b. Yeah? Well, that means that b has to be negative 2. Now, in terms of big picture, they typically will not throw you a bone and allow you to find it slope field wise. But the idea goes like this. If you were to really get a big slope field and draw all the possible equations, you'd see over here a lot of curves this way. And over here, you'd see a lot of curves this way, concave down. But in between, you would see this little border line. It's actually linear. And that's what you do. Okay, 133 is due today, but we'll finish 135 practice Monday. Have a nice weekend.
Look what I did. I did one with a coin and I did.
You did what?
So
1.4, didn't you think, God, that's really
yeah,
weird?
I did. And I was like, why would I do this? But I did it.
I did it. It's like, go Nazi. I don't know what it is. I'm just
I
going
was
to
at
keep going.
stop. I was at 1.2.5 and then I did about it. And then I did the triangles so it's not too hard.
You just make it.
I think it's pretty hard doing
I
certain
think so.
things and doing your fault.
I feel like you should have just said something weird. I just
Pretty
thought,
creative.
that's right. It's pretty cute. Alrighty. Have a great weekend.
Just need
Yes.
why do you just subtract? Like, why do you just subtract the not that problem, like part A
Oh,
or part B? I mean, like, why do you subtract the 1 minus or the 1.2 minus 1?
really, I'm just trying to say, in my mind, I'm saying, where am I going from and to? I'm going from an x of 1 to x of 1.2. They want me to get to x of 1.2. And so the only way to get from 1 to 1.2 is if I add, right? Now, as far as you subtract, you always subtract because it's always n minus star. But don't worry about memorizing the formula. Just say from where I want to go from and to, am I increasing or decreasing? Use that for this. Don't worry about memorizing. Okay? Okay. Hey Dan, this is Corey Rickman. How you doing? Good. Hey, I just got a pass for Olivia O'Brien to come see you, but she wasn't here. I didn't want you to think she was blowing you off. She's just not here, and I didn't catch the pass person before she left. No problem. See ya. All right.
Gary, I had a very creative way to solve that one when it was printed wrong.
What's that?
Well, then I realized it was probably the dumbest thing I could have done.
Yeah, I know.
I approximated to f of 2.4 and divided by 2.
That's what Harper did. She said that's creative. I think that's weird.
That's
That's
genius.
weird. Oh, what?
Everyone knows that f of 2 is double f of 1.
So you thought I meant to go past it, then go half back?
Well, I mean, that's the only thing that made sense. Like,
I think what made sense is that's got to be a typo. This doesn't work.
Yeah, that's what I was thinking.
Full of tests.
Oh,
Yeah, I just left it
Yeah.
because I was like 0.14. This doesn't make sense.
that works.
very beautiful. You're real outside of the short. Ooh, you're outside the box.
It would have worked if they were x values.
Let's see. That's so neat. Yeah, I was supposed to help you map the windows, darn it.
Are you proud of us for doing math on Friday?
I am proud of you. That's pretty great.